It is review day. Forgive me for being next door teaching freshman algebra, but we're going to get this done together. So hopefully you guys have the review in front of you, and hopefully you have all the really cool identities. You're welcome. You're welcome. You're welcome for me doing this for you and giving these all to you. There's some things like, for instance, this is supposed to be a tangent of theta, but you know that the tangent sine or cosine. All of this goes together. That's the formula, and that's how you find theta. That's how you find k. That's a square of just x. That's not a 2x. I had some really nice person do this for me, and they didn't do a perfect job, but they did a great job. So it's a tangent squared of x. Let's see, what are the little tiny mistakes? That's a cosine squared there, and that's a tangent squared. And this x plus y here is really an x plus y over 2. Okay, so those are the notes we got today. This is a 1 plus, right here, that's a 1 plus tangent squared, but that's up above me on the board, so all of those are there. So hopefully this is everything you know and need, and it was a pretty good job of typing all this stuff up, but it's not perfect. Oh, same thing, that's a squared, and that's a squared. Those aren't backwards too. That's a cotangent squared. Cosecant squared, okay? Tangent squared. So, here we go. Let's get started with this, all right? So, number one, we got a tangent squared minus a secant squared, okay? So, how do we do this? Well, if I look up above me and point up in blue, tangent squared minus secant squared, it's going to be 1. It's just 1. Or it's in your identities, I think, somewhere. Probably is. Pretty sure it's in your identities. Let's see. Oh, yeah. How about right... It's in here somewhere. It's one of these. Tangent squared minus secant squared. Tangent squared minus secant squared. No, it's secant squared minus tangent squared. So it's really -1. It really is a -1. It's the other way around. Okay. Anyway, we know that secant squared theta minus tangent squared theta is equal to a 1. So a tangent minus secant is equal to a -1. Okay, good enough. Anyway, number 2, and I'm probably going to need a little bit of space to do this stuff, so I'm going to use a separate sheet of paper. So let's take a look at how to do number 2. Number 2, I've got a cosine. So number 2, I've got a cosine. I like thetas. Theta secant theta over a tangent theta. Change the secant into 1 over cosine. I'll change the tangent into sine over cosine. So let's rewrite this. Cosine theta times a 1 over cosine of theta. Hey, I like that. All over a sine theta over a cosine theta. Okay, secant is 1 over cosine, tangent sine over cosine. Cosines cancel. I'll be left with a 1 over a sine theta over a cosine theta. 1 over any fraction is going to flip up the fraction and change it to cosine theta over sine theta, and that is an identity that's cotangent of theta. There we go. Alright, number 3. Again, I'm going to use some scratch paper. It's going to take some room. So let's go. Sine, and I'll change it to thetas, of 2 theta over 1 plus cosine of 2 theta should equal a tangent of theta. Okay, so I'm going to use my identities. So I'm going to use my double angle identities. If I look at my sheet, my double angle identities are here. So I'll change the sine of 2x into 2 sine cosine, and I'll change the 1 minus cosine. I'll change the double angle here, probably to make it easy. Oh gosh, let's see, we can put everything in terms of cosine, couldn't we? If I do this one, then the ones will cancel. Okay, so I'm going to use that one right there and that one. Okay, on top, let's rewrite it. So, this is going to make a 2 sine theta cosine theta. It is that identity over a 1 plus. I think I want to, there's 3 of them we could use. I think I want to use this one because the 1s will cancel. Over a 1 plus a 2 cosine squared theta minus 1. Okay, so the 1s will cancel like that. I'll be left with 2 sine theta cosine theta all over a 2 cosine squared theta. 2's will cancel for sure. I can cancel a cosine for one of these cosines. That'll leave me a sine theta over a cosine theta, and sure enough that is equal to, sine over cosine is equal to a tangent of theta. Tangent theta. I've got it. I've got an identity equal to an identity. Okay? Alright, that was number 3. 4. Okay? 4. Okay, there's 2 ways to do 4. I'm going to do it as subtract. Go ahead and turn the page, and I'm going to go continue to use scratch paper. So number 4, I've got cosine of 15 degrees. So cosine of 15 is really the same thing as cosine of 45 degrees minus 30 degrees, both of which are on the unit circle. So I'm going to try and find my plus minus angle. So I'm looking for cosine. I'm really looking for cosine of theta minus phi. Okay, I'm looking for that one. And it is right there. And of course, this one's got s and t's like the book puts it, but it's going to be the cosine s and then cosine t plus sine s and sine t. So we're going to write this as a cosine. So it's cosine theta cosine phi plus sine theta sine phi, which is going to be, here's my theta and there's my phi. I'll go cosine 45 cosine 30 plus sine 45 sine 30. So I'm just using my identity. Now I'm going to use the unit circle. Cosine of 45 is the square root of 2 over 2. Cosine of 30, which is the x value, is square root of 3 over 2. Plus sine of 45, y value, square root of 2 over 2. I just got that from the unit circle. And sine of 30, which is the y value from the unit circle, is a 1/2. Alright, simplify. Square root of 6 over 4 plus square root of 2 over 4. They have a common denominator of 4. Let's just write the 4. We'll write this as square root of 6 plus the square root of 2. We're done. Okay, that was number 4. Okay, let's look at number 5. Okay, shift this up. Number 5. Okay, so 5, we're going to take a tangent of 165. Let's see, how can I make 165? Well, how about 120 plus 45? How about tangent of 120 plus 45? So I've got my theta and my phi. So I'm going to try and find that in my identities. And it's that one there, tan of s plus tan of t over 1 minus tan s tan t. I'm going to use thetas because I like thetas better. So my formula says I'm going to go and rewrite this as a tan of theta plus a tan of phi over a 1 minus tan theta tan phi. Alright, theta is 120 degrees, phi is 45 degrees. Let's plug them in and then we'll evaluate them. Let's go tan of 120 plus tan of 45 over 1 minus tan 120 tan of 45. Okay, we'll go to the unit circle now. Tangent of 120 is negative square root of 3. So we have negative square root of 3 plus tangent of 45 is 1 over 1 minus tan of 120 we found was negative square root of 3 times tan of 45, which is 1. If I simplify this, I'd have a negative square root of 3 plus 1 over a 1 plus a square root of 3. And that answer is good enough. If you want to rationalize this and fix this for a bonus half point on the quiz, I would take that. Okay? Number 6. We're moving along. Okay? 6. We have sine of 5 pi 12ths. Alright, so that's got to be something plus something. So let's rewrite this as sine of, oh, how about 3 twelfths plus 2 twelfths? Because it does make 5 twelfths, and the reason I like that is because if you reduce it, you get sine of pi fourths. Hey, that's on the unit circle, plus pi 6. Hey, that's on the unit circle too. Okay, so I'm looking for sine of, we're looking for sine of theta plus phi. Look at my addition sheet, and I find it right. I'm looking for it. It is right there. Okay, it's right there. Sine theta plus phi. It's going to be sine theta cosine. So I'm going to just rewrite that for us. So we're looking for a sine theta cosine phi plus cosine theta sine phi. That's our identity. Let's plug in pi fourths and pi 6. Okay, so we'll go sine of pi fourths cosine pi 6 plus cosine pi fourths sine pi 6. And we'll just use our unit circle. Okay, go to the unit circle. Sine of pi fourths, it's the y value, square root of 2 over 2. Cosine of pi 6 is the x value. It's going to be the square root of 3 over 2 plus cosine of pi fourths, it's the x value, which is square root of 2 over 2. Sine of pi 6, which is the y value, which turns out to be 1/2. We get the square root of 6 over 4 plus the square root of 2 over 4. They have a common denominator, which is 4. We'll wind up with square root of 6 plus square root of 2 on top. Square root of 6 plus square root of 2. And that is the exact value. Okay, number 7. Okay, let's see if it gets any easier. I think so. 7's not too bad. Slide it down. Okay, so 7. We've got the sine of a plus b. We're going to find that if sine of a is equal to 3/5, and that's in quadrant 2, and tangent of b is 12/5, and that's in quadrant 3. Okay, anytime we see a quadrant, let's build a triangle. Quadrant 2, angle A, right? Angle A, quadrant 2. Sine is the opposite over the hypotenuse, which makes this 3 over 5. And hopefully you know this is 4. Hopefully 3, 4, 5 triangle. You can do the Pythagoras Theorem, but hopefully you know that's 4. So it's a -4 because we got to go back. Okay. Put a triangle in quadrant 3. Call that B. Opposite over adjacent. 12 over 5. But really, they're both negative because if I graph it, I have to go back 5, down 12. So it's a negative. And if you do Pythagoras Theorem, this turns out to be 13. Okay, try it. 5 squared plus 12 squared, it does equal 13. Okay, so that's 13. So now let's take a look at sine of a plus b. So I'm going to go ahead and find that in my, here it is. I'm going to use this formula right here. So we're going to write it as sine of a cosine b plus cosine b, oops, that's cosine of a sine of b. That's my formula. There's my AB. Alright. So sine of a, that's easy. Sine is opposite of hypotenuse. That's just 3/5. Cosine of b, we got to go to angle B, go over to triangle B. Adjacent of hypotenuse, which is -5/13. Plus cosine of a, adjacent of hypotenuse, which is a -4/5. Sine of b, sine is going to be opposite of hypotenuse, which is a -12/13. Alright, so let's simplify. -15/65 plus 48/65. What's that, a 33/65? I think so. 33/65. That wasn't so bad. We could do that one. Okay, number 9 is pretty similar. Okay, I'll take, number 8. Okay, number 8 is easy. Swoop this away. Let's do 8. All right, number 8. Okay, so number 8 says we've got to express 8 sine x plus 15 cosine x in the form of k sine x plus theta. Hey, I've got that on my identity sheet. In fact, I put a big circle around it because it's got all of these different parts, okay? So the first thing I want to do is find k. So k is going to equal the square root of 8 squared plus 15 squared. And I think that's 17. I think if you use your calculator, it's 17. Oh, hold on. I need a calculator to do this anyway. So I thought I had a calculator. Hold on. Watch me find one where the batteries are dead. Of course. So let's see, what is 8 squared plus 15 squared? Yeah, square root of that is 17. Yep. Okay, so k is 17. Let's find theta. So I've got two choices. I could either use the cosine of it or the sine of it. May as well just use the cosine. So I'm going to say cosine of theta is equal to a, which is 8, over 17, because that is the square root of 8 squared plus 15 squared. Okay, so I'll go cosine inverse of 8 17ths, degree mode. So let's do that. I'm going to go clear. I'm going to go cosine inverse of 8 divided by 17. And I get about 61.9. So let's rewrite it in this form. So let's go k, which is 17, sine of x plus theta, which is a 61.9 degrees. That is an equivalent of our original statement, okay? That is number 8. Okay, 9. Okay. Scoot my paper up for 9. Alright, in 9, so we know cosine of x is equal to negative 4/7, but that's in quadrant 2. And I know that I have to find the exact value of cosine of 2x, and I need to find the exact value of sine of 2x. Okay, so cosine of 2x, really have three choices. You could use the first one, the second one, or the third one. I'm just going to use the third one because it's already in terms of cosine. So I'm going to use the third one. Any of them will work. They'll give you the same answer, but I'm just going to use the 2 cosine squared of x, right? And with the sine of x, I'm going to use its identity, which is a 2 sine x cosine of x. Now let's build a triangle and finish it up. So I build my triangle in quadrant 2. Here's my angle x. Okay, cosine is the adjacent over the hypotenuse. Probably better get this because I'm going to need the sine. So find the opposite. I'll just use Pythagoras Theorem real quick. Let's see, 4 squared plus b squared equals 7 squared. Let's see, b squared is equal to 49 minus 16. What's that? 33. So b is equal to the square root of 33. Okay, put that up there. That's my adjacent or my opposite side. Okay, let's figure this out now. So here's my identity right there. So cosine of 2x is equal to 2 cosine squared of x. So cosine is equal to negative 4/7. So we'll go 2 times negative 4/7 squared. So just plug in for cosine my negative 4/7 squared, and I get 16 squared, and I get 49 times 2. 2 times 16 is a 32. 49. So that is the exact value of the double angle. Now for the sine, here's the sine of 2x, here's my identity. So we'll go 2. Now the sine of x is the opposite over the hypotenuse. Square root of 33 over 7. Cosine is, we already know, is negative 4/7. So let's simplify. I'll get a negative 8 square root of 33 over 7 times 7. 49. Okay, there it is. Okay, let's do number 10. On page. Let's get number 10 done. Okay, now the exact value. I'm going to use a half angle. Number 10, I've got the tangent of 22.5 degrees. I'm going to use a half angle because I know that half of 45 is a 22.5 degree angle, okay? So I'm going to set up for the half angle. So I want really tangent of theta over 2, where my theta is equal to 45, okay? So find that on my sheet. Half angle for tangent. And it's right, oh, hold on. It's right there. It's either one of these. I don't know. How about I use the first one? That way I don't have to worry about the denominator, okay? So let's set it up as 1 minus cosine theta over sine of theta. So we know theta is 45, right? So go 1 minus cosine of 45 over sine of 45, because theta is 45. Now go to the inner circle. 1 minus square root of 2 over 2 over square root of 2 over 2. Now that's a really ugly answer. So let me fix it up a little bit. Change 1. The number 1 can be changed into 2 over 2. So let me do that. I'm going to go 2 over 2 minus the square root of 2 over 2. Okay, just change the 1. There's my 1 all over square root of 2 over 2. Okay, now I can combine these two because I have a common denominator. And I can rewrite those two as a 2 minus the square root of 2 over 2. But it's divided by, so let's flip this fraction, times, flip it, 2 over the square root of 2. 2's cancel. And we'll be left with 2 minus the square root of 2 over the square root of 2. Now, you probably ought to rationalize it, but I'll leave that for you. I'll take that answer, but if you, on the quiz, rationalize it, I might give you a half bonus point, okay? 11. And I hope you guys having fun. Woo-hoo, yeah, I bet you're having fun. Okay, 11. Hey, we're almost done. Okay, this is kind of the stuff that we learned today, but it's really super easy. Okay, 11. We want to write tangent of 2 sine inverse of x as an algebraic expression in terms of x. Okay, so how are we going to do this? Okay, well, here is the trick. Okay, listen very carefully. Okay, this is an angle. Anytime you do an inverse of something, it's an angle. So let's rewrite this whole thing as tangent of 2 theta. Okay? So I probably ought to build a triangle. And if I build a triangle, then I can make an angle theta. So let me build a triangle here, okay? Here's my theta. And what I know about sine is it's the opposite over the hypotenuse. All right. Probably need the adjacent because I look at the tangent formula for double angle tangent. Double angle tangent, double angle tangent. I'm going to find it in a second. Oh yeah. Actually, you know what? I might not need, well, yeah, I'm going to need it because I'm going to need the opposite over the adjacent. So I need the opposite. So, okay, I need to find the adjacent side. Okay, so let's do that. By Pythagoras Theorem, I can have an a squared plus an x squared equals a 1 squared. Or a squared is equal to 1 minus x squared. Or a is equal to the square root of 1 minus x squared. Okay, so I'm trying to find the adjacent side with Pythagoras Theorem in terms of x. So when I do that, I got a squared plus b squared equals c squared. But it's a squared plus x squared equals 1 squared. And when I solve it all the way, I get this side, the adjacent side, to be the square root of 1 minus x squared. Okay? Now, let's look at our formula. Okay, the tangent of the double angle. So my tangent of the double angle, if I look at my notes, here's my tangent double angle. It's equal to a 2 tangent theta over a 1 plus tangent squared theta. Okay, that is my identity. Tangent 2 theta is equal to that. Okay, that's my identity. Got that in my notes. All right, so tangent is equal to opposite over adjacent. So let's do this. Tangent of 2 theta would equal, okay, 2 times the tangent. Okay, now the tangent of theta, opposite over adjacent. So we're going to get an x opposite over its adjacent over the square root of 1 minus x squared. All over 1 minus my opposite of adjacent squared, my x over my square root of 1 minus x squared, and then squared. That is a mess. Okay, let me simplify this a little bit, and then I remember this from last year. We're going to give an much easier question on the test. So to simplify it a little bit, I'll have a 2x over a square root of a 1 minus x squared all over a 1 minus an x squared all over a 1 minus x squared. Okay, and we don't need to go any further than that. I will show you later when I'm here how I can simplify that further. It deals with a common denominator, then inverting and multiplying, but we'll just take that answer. Okay, it's pretty good math to simplify this stuff I like. Okay, finally 12 and 13, which are amazingly easy. They really are, trust me. 12. So we're going to express cosine 3x sine 2x as a sum of trig. So sum. Okay, let's remember this is theta and this is phi. So this is what we learned today in our reading. It's actually pretty easy. I'll show you how it works. So if I go to my formula, what I'm looking for is cosine sine. Cosine sine. It's right there. Okay, I want to use that one there. Okay, so I'm going to rewrite it as a 1/2 parentheses or brackets sine of theta plus phi minus sine of theta minus phi. Okay, so I'm just using my identity. This is the one we got in our reading today. Alright, so all I need to do is put my 3x and my 2x in. So I'm going to have a 1/2 sine of a 3x plus a 2x minus a sine of a 3x minus a 2x. So I just put my 3x here, my 2x there, 3x there, 2x there, and just simplify. I get a 1/2 sine of 5x minus the sine of an x. And there's really absolutely nothing we can do with that. You cannot subtract them. They're different angles. You're stuck. End of story. That wasn't so bad. Just use the formula, plug them in. Okay, now if we go to 13, which is the last one, we're going to do just the opposite, okay? So 13. If we start off with a cosine of 5x plus a cosine of 3x, we want to do as a product. So let's look at the notes I gave you today, okay? Cosine, cosine. It's that one there. It's that one right there. You see it? Cosine of x plus cosine y. So let me write it in terms of thetas and phi's. So my formula said we're going to write it as a 2 times cosine of a theta plus phi over 2 times a cosine of a theta minus a phi over 2. Okay? Alright, that's my theta, that's my phi. Let's just, whoop, that's a phi, my bad. Let's just put them in. 2 cosine of 5x plus 3x over 2 cosine 5x minus 3x over 2. Alright, so I just plugged got my formula, plug my 5x here, 3x here, 5x here, 3x here. Now let's just simplify it. We'll get a 2 cosine 8x over 2 cosine 2x over 2